Welcome to lecture series on data structures. So in the previous lecture series, we have seen what is a data structure and what are the types of data structure. We have seen under types, we have seen what is primitive and non-primitive data structure and the classification of non-primitive data structure. We have seen to assessment and we have discussed about the various operations that can be performed in a data structure. So in today's lecture, we will see how to implement the data structure. In general, data structure can be implemented in two ways. One is it can be implemented with the help of array or it can be implemented with the help of linked list. So I'm not going to discuss about array implementation in detail, but uh, uh, let me give an overview about what is array implementation of data structure. So how do we store elements in an array? It is stored in linear format, right? So we have array indexes. Initially, we will specify the size of the array. I mean, by size, we mean the number of elements that I'm going to store in the array. So either you can specify the size dynamically or you can specify the size statically. So array index obviously, so look at this figure. Array index starts from 0. So elements will be stored from the 0th index onwards. So one major drawback of array implementation is array elements of similar data types only can be stored in array. But you could ask here. We have two different types. One is 23, other one is an alphabet. They may ask 23 is number and A is a character. So two different data types are there. But I've told like two different data types cannot be stored inside a same array. But I can consider this as a character. 23 can also be considered as character or a string. So similar data types are stored inside the array. That is one major drawback of array implementation. So when it comes to linked list, and another drawback of array implementation is if you look at this figure, size of the array is 5, which means I can store maximum of 5 elements or less than that. But if I want to store a sixth element into this array, or if I want to insert a sixth element into this array, expanding the size of array will be difficult process. So array size cannot be resized. That is one major drawback. Another major drawback of array implementation. So to overcome these drawbacks, we go for linked list implementation. So in case of linked list implementation of a data structure, the size can be dynamically expanded. So you can store n number of values inside, or you can insert n number of values into a linked list. So here, uh, unlike array, if you look at the linked list, each value is inserted inside a separate box, right? So this box, we call it as node. So in case of linked list, the data is stored inside a node and nodes are linked together. That is why the name linked list. So here at few places you could see single arrow, and few places you could see a double arrow, right? So if we have only forward link, it means the given linked list is singly linked list. So in case of singly linked list, each node is linked only in one direction, which is forward direction. On the other hand, in case of doubly linked list, each node is linked in both the direction, both forward as well as backward. First node in the linked list is called as header node, and the last node in the linked list is called as the tail node. So how do I find the tail node is that in case of any linked list, see, each node here, if you see, each node will have actually two field. One is data field, other one is a pointer field. So that let me explain when we are looking at in detail about linked list. But for now, you understood what is array implementation. You understand what is a linked list implementation. You get to know the drawbacks of array implementation of a list and why we move on to linked list implementation. So let us have the difference between an array and linked list implementation. So if you want to search a particular element, obviously array is the best choice, but it has its own drawback, like insertion and deletion is a time consuming process. If I want to insert, for example, here, if I want to insert a value of 23, or if I want to insert a value of 2, I have shift all the 4 elements one position next. Now here the size of array is 5, so you may not know a huge of a difference, but assume the size of the array is 5,000, and if I want to insert an element in the second position, I have to shift 4,999 elements, which is a time consuming process. Similarly, same goes for deletion. If I want to delete the second element, I have to shift one position left, one position before. If the size is 5,000, I have to shift 4,999 elements. So both insertion and deletion is time consuming process. But in case of linked list, insertion and deletion is easier. So I need not shift any elements. All I need to do is change the pointer position. Whereas searching is difficult. So a sequential traversal from the beginning of the list requires to search for an element until it is found or up to the end of the list. So hope you understood difference between array and linked list implementation. Thanks for watching. Keep watching. In the next lecture, we will discuss in detail.